Integration using substitution. Let's start by looking at an example with fractional exponents, just a nice simple one. Before I start that, we're going to have quite a lot of this sort of thing going on where we get some kind of fraction on the bottom of a fraction and it gets confusing. So what we should do is think about this as like 1 divide and then 3/2. When I divide by a fraction, what I should do is multiply by the reciprocal, and this just gives me 2/3. Now here's a simple integration here involving a fraction. So when I'm integrating this sort of thing, I should add 1 to the index and then divide by the new number. So I'm going to have something like this. I'm going to have on the top v and then 3/2 over 3/2, because a half plus 1 is 1.5, and then divide by the new number, plus k. Now this thing looks a bit untidy, but I can use what I had up here. I can just type this as 2/3 of v to the 3/2 and then plus k. Now normally I don't even do it like this. I don't have this step in the middle, I just go straight to this. Yeah, add 1 to the index here, you get 3/2, turn it upside down in your head, 2/3 times v to the 3/2 plus k. But put this step in the middle if you're not sure what's going on. Great, let's move on to the main problem now. What we want to do is we want to integrate the square root of 5x minus 4. So the first thing we should do here is realize that square root 5x minus 4 can be written as 5x minus 4 in brackets to the power a half, and then put dx. Now with this sort of problem we should do some substituting, and the normal substitution to do is u equals 5x minus 4. I've chosen 5x minus 4 because that's what's in brackets here. The step that you do after that is always du dx, and du dx in this case is 5. Now as part of the substitution I'm going to replace this with u, and this will become u to the half. But I've got a dx here and I can't have a mixture of u and dx. I've got to do something about it. So I write the expression that I've just done, du equals 5 dx, and one more step, I'm going to have 1/5 of du equals dx, and all I've done now is divided both sides of this by 5. Okay, now what I've got to do next is do these substitution steps. So I take this and just paste it in here, and now ready for the substitution. 5x minus 4 I've said is now going to become u, and 5x minus 4 was to the power half, so I must do it to the power half. dx is equal to 1/5 du, so I do du, and where should I put this 1/5? Well, the best place to put it is out the front like this. It's just a constant, and so I can just put it out the front. So here I've got some expression involving x with a dx. This is correct. I've got an expression with u and du. This is also correct. In this work, don't mix up your x's and du's. It gets very confusing and probably incorrect. Okay, so I just do that 1/5 again, and now what I have to do is I have to integrate u to the power half du. But this is just like the problem I did above, isn't it? Let's go and have another look quickly. Yes, look, I had integral v to the half dv, and I did it like this. Well, do the same thing down here. The integral of u to the half du is going to be 2/3 what we got before, 2/3 u to the power 3 on 2, and then plus k. The 3 on 2 comes from adding 1 to this. 1 plus a half is 1 1/2, or 3 on 2, and the 2/3 comes from dividing by 3 on 2, or multiplying by 2 on 3. Then, let's tidy this up. We're going to have fraction out the front, 2 over 15, and it's going to be u to the power 3 on 2 plus k. Now, we're almost finished, but not quite. What we want to do now is express this back in terms of u. If we don't do that, it's incorrect. We started with x, we should finish with x. Now, it's always a very good idea to have a clear statement of u, because you always have to substitute back again. I go and look up here, here is my clear statement of what u is, and so I substitute back into here. 5x minus 4, and raise it to the power 3 on 2, because that's what it says, and then plus k. And that is the end of the story.